Hello, my dear students. Myself, Dr. Kololini Banerjee. Today, I'm going to discuss one very important topic from your syllabus, that is VLSI design styles. For discussing various VLSI design styles, I should first tell you the full form of ASIC, that is Application Specific ICs. And ASICs can be broadly classified in three design, that is full custom ASIC, semi-custom ASIC, programmable IC designing. This programmable IC designing is again can be divided into PLD and FPGA that I will discuss in my uh, next lecture. But in this lecture, I'm focusing on this full custom ASIC and semi-custom ASIC. So semi-custom ASIC can be again broadly divided into gate arrays and cell-based arrays. So gate arrays are divided into channeled and channelless designs, and cell-based arrays actually majorly this is standard cell-based arrays, and there is another that is macro cell, and I will discuss one by one. This programmable device, that is field programmable devices, are divided in this PLD, that is programmable logic devices, and FPGA, that is field programmable gate array. And PLDs are again classified into these simple programmable logic devices and complex programmable logic devices. And SPLD is like PROM, programmable read-only memory, PLA, that is programmable logic array, and programmable array logic. So let us start with full custom design. In this full custom design, actually the entire mask design is done anew without use of any library. So what actually I am telling, that in this method the function and layout of every single transistor is customized and optimized by the designer. So actually a designer can craft all the circuits by hand. Okay, so this method increases the performance of the chip potentially and minimizes its area, but it is very rigorous to implement. So circuit complexity, designing complexity is very high. The development cost of such a design style is obviously higher. The concept of design reuse is becoming popular to reduce design cycle time and cost. Okay. So moving forward, the most rigorous full custom design can be the design of a memory cell. It can be static or dynamic. I'm not reading out all these things. Let me discuss that. The next slide, very important. In real full custom layout, in which the geometry, orientation, placement of every transistor is done individually by the designer, that is by hand, their design productivity is usually very low. Okay, that is why. So it is typically, it is found from the industry data that typically it is 10 to 20 transistors per day per designer. So what, for this reason, this is not very much acceptable in the industry. In digital CMOS VLSI, full custom design is rarely used due to high labor cost. Okay, so exceptions are also obviously everywhere there will be exceptions, and exceptions to this include the design of high volume products such as memory chips, high performance microprocessor, and FPGA masters, etc. So this is all about the full custom design. Let me discuss on the semi-custom design, the next one. So significant portion of the chip is developed using pre-designed and pre-verified components such as standard cell libraries, memory blocks, and intellectual property codes. Designers focus on placement and interconnection of these components to achieve the desired functionality. This approach is basically balancing the customization and efficiency offered by middle ground between full custom and off-the-shelf design is actually the fixed design. So this is actually one trade-off or one balancing option in between this full custom and off-the-shelf design. So in this semi-custom design, actually the gates or components are pre-designed and they are in fixed location on the chip. There will be some cell libraries. So it is actually classified into standard cell or macro cell or gate array. These are the divisions. So we have some pre-designed and pre-verified libraries which are actually designed using the fixed designing. And here we have finally reached towards this difference between full custom and semi-custom design. So in this full custom design, complete design, implementation, placement is done from transistor level, obviously from the scratch level. But in semi-custom design, we use pre-designed and pre-tested module for designing. I have already told you. So obviously full custom designing is of higher cost and it is of lower cost. So more design time required in case of full custom design, but less time required for semi-custom design. High circuit performance is actually offered in case of full custom design. This is the main advantage of full custom design. But there is low circuit performance, less dependency on the existing technology as it is fully customizable, and here more dependency on the existing technology as there will be some predefined cell libraries. In full custom design, it can be used for mass production as the performance is very high. But in case of semi-custom, it cannot be used for mass production. Complex circuit layout, it is already discussed. Here it is simplified circuit layout. Full custom design is very high speed, is of very high speed. Semi-custom design less speed compared to full custom design. So for example, we can say in case of microprocessor chip design, we use full custom design, and semi-custom designing is broadly used in digital logics, like in CMOS designing, we use this semi-custom kind of designing. So this is all about my today's lecture, that is on full custom and semi-custom design styles of VLSI designing. And in my next lecture, I will start with the fixed designs, like the programmable designs, where I will discuss the PLDs, FPGAs, etc. Thank you and stay tuned.